Hi, Matt here, bringing you a tech tip from Uniweld products. Today we're going to show you how to braze a copper fitting with nitrogen flowing through the line to prevent oxidation. I'll explain more about that later, but let's go ahead and get started. I have two pieces of copper set up here. My bottom piece is open on both ends and exposed to the ambient air. And my top piece of copper on one end has a brazed access fitting, on the other end is open. Attached to my access fitting I have my nitrogen tank. Now we're going to braze two copper fittings together, one on the bottom line and one on the top line with the nitrogen flowing through it, and we'll take a look at the difference. First we will open up the nitrogen tank, and using Uniweld's RHP 400 nitrogen regulator, I'm going to dial in the delivery pressure to 40 psi. Now when I'm brazing, I only want the nitrogen to flow at 3 CFH. That's cubic feet per hour. If there's too much flow, the nitrogen will push back, causing pinholes and won't allow the joint to seal properly. To achieve this low flow, I have Uniweld's UNF3 nitrogen flow indicator connected to my regulator, and this will provide me with the control to lower my flow to 3 CFH. When I open the valve of the UNF3, you see a float ball in the flow indicator tube. This gives you a visual confirmation that the nitrogen is flowing. If the float ball does not rise, this indicates that there is static pressure and no flow. The system must be open for the nitrogen to flow through the copper lines and escape, so the valve cores must be removed from both the high and low side access fittings. Once I have purged the lines of any air, I will dial back the flow of nitrogen to 3 CFH. Now I'll go ahead and braze these two joints. I'm using Uniweld's oxyacetylene outfit and our MTF5 Captain hook tip. This is a 5-flame tip that directs all the heat onto the copper and provides 100% wraparound on the tubing. When brazing copper, the combination of the heat applied and the presence of oxygen in the ambient air causes a chemical reaction and forms a layer of copper oxide. This is the black, flaky scale that you see on the outside of the copper tube. And this copper oxide will also form inside the tube and can cause many complications such as clogging the TXV valve. The flowing nitrogen displaces all the oxygen that was inside the copper line, preventing oxidation and the resulting scale. So the inside of the tubing will remain perfectly clean. Now that our joints have been brazed together, let's take a look at the difference. First, let's look at the joint brazed without the nitrogen flow. I'm just going to take a wet rag and clean up the outside of the tubing, and as I tap on this white piece of paper you can see all the scale that falls out of the tube. Now I'm just going to snip the tube open so we can see the inside, and you can see all the residue that's still stuck on the copper. Now let's look at the fitting brazed with the nitrogen flow. I'm going to clean up the outside of the tube again, and as I tap on the paper you can see that nothing falls out because there was no oxygen present for the copper oxide to form. And I'll snip this one open now, and you can see the copper looks like brand new. By using Uniweld's RHP 400 nitrogen regulator and UNF3 nitrogen flow indicator, we were able to braze a joint and keep the inside of the copper clean by displacing all the oxygen inside the line with a slow flow of nitrogen. You can find more information on our website at uniweld.com, and be on the lookout for more tech tips coming soon. Thanks for watching. I'm Matt with Uniweld, quality tools that go to work with you.